So the last video in this unit is reaction yields. This is actually a pretty straightforward video, so hopefully you won't have too much trouble with it. So let's again start with a definition, and then I'll talk you through an example. Yield of a chemical reaction. What is that? Here's the thing. Most reactions do not produce the exact amount of product that is predicted by the balanced chemical equation. So basically, anytime you guys do a lab, you never get 100% of the product that you're supposed to get. There's always a little bit lost. So number one, the theoretical yield, that's the maximum possible mass of product that could be produced in a chemical reaction. And this is based on your stoichiometric calculations, okay? Your actual yield is the mass of the product that you actually obtain from a reaction. So this is the one that you would do in a lab. And then the percentage yield is a method of expressing how efficiently a reactant can be converted into a product in a chemical reaction. So how good, how efficient were your lab skills? There's an equation for this. To find the percent yield, we take the actual yield. Again, you get the actual yield right from the lab. The theoretical yield is what you calculate based on your mole ratio. You times it by 100 and you get your percent yield. So it's a pretty straightforward calculation. Oh dear. It's a pretty straightforward calculation, but let's go through it step by step just to make sure you've got it. There we go. So example number one, bromine was made according to this following reaction. So I've got HBrO3 plus 5HBr gives you 3Br2 and 3H2O. So it's very nice and gave you your balanced chemical equation here. If 10 grams of HBrO3 was reacted with an excess of HBr and 26.3 grams of Br2 was produced, what was the percentage yield of the reaction? So in this case, I'm doing a couple of things for you. Number one, I'm telling you that your limiting reagent is HBrO3 or bromic acid. Okay? The reason why I'm telling you that is because the excess HBr automatically tells you if this one's in excess, then the other one has to be your limiting reagent. Okay, so I'm telling you that HBrO3 is your limiting reagent. You don't have to figure that out. So you can just use your 10 grams as your number and use that to find out how much Br2 was made. Okay, so I'm starting with HBrO3 and I'm converting it to the amount of Br2 that's made. The question also says that 26.3 grams of Br2 was produced in a lab. In the lab. So that's going to be my actual yield. Okay, so what do I have to do? I have to first calculate my theoretical yield and use that to actually find the percentage yield of the reaction. Okay, so step one, to find the theoretical yield. So theoretically, I should make a certain amount of Br2 if I have 10 grams of HBrO3. How much should I make? So let's start by using, I want to find the number of moles of HBrO3. So I'm going to, again, write down what's given to you in the problem. So I've got 10.0 grams times 1 mole divided by the molar mass of HBrO3, which is 128.91 grams. So I do 10 divided by 128.91, and I get 0.0775735 moles of HBrO3. So now I'm going to use my mole ratio to find the number of moles of Br2. So I use 0.0775735 moles of HBrO3. That's what I calculated in my last step. And I times that by my conversion factor. So in this case, you have a 3 in front of Br and a 1 in front of HBrO3. Br2 has to go on the top, and 1 HBrO3 has to go on the bottom. The reason we do that, again, so the HBrO3 cancels out, and I end up with Br2, which is, oops, sorry. So I take that and I get 0.23272 ... moles of Br2. And then my last step would be to calculate the number of grams of Br2. So again, I take 0.23272 moles of Br2, and I'm going to multiply that by the molar mass, the grams per mole. So in this case, I've got 79.9 times 2, so 159.8, and I take that, and I end up with 37.1886 ... grams of Br2. So this is my theoretical yield, or TY. Thank you. What I'd like to do right now is, because I'm running out of room on the board to actually calculate the percentage yield, I'm going to erase a lot of this. So I'm going to show you how you could have done all this stoichiometry in actually one step. Okay, so I'm going to write in black. So the stuff that I'm writing in black is the stuff that I've already written down, but I'm just going to quickly show you how to do that, because this is going to be a short video anyway. So what I can do, if I go up to here, I can actually calculate, instead of calculate the moles of HbRO3, I'm going to erase that, and I'm going to calculate the number of grams of Br2, given that I started with 10 grams of HbRO3. So if I do that, I'm basically just going to take all three conversion factors and write them in a row. So I have my 10 grams divided by 128.91. That's still good. Nothing wrong with that. What I'm going to do now is take this and put it in up there. So I'm going to multiply it by 3 Br2s over 1 HbRO3. And then I'm going to take my last conversion factor down here and write that up there. So times 158.9 grams in 1 mole. So I can do basically all that in one step. If that makes no sense to you, then ignore what I just said and don't worry about it. I'm just, for those of you who are sort of a little bit ahead of this, you can do all of that in one step instead of many steps. So now let's clear the rest of the board. Very slowly, apparently, today. No, my tricks aren't working. Oh my goodness, my eraser's not working very well either. Okay, there we go, good enough. So this was 128.91 grams. Okay, so I can do that whole thing. So 10 divided by 128.91 times 3 times 158.9, I get 37.18. I'm going to go back and use three significant figures. So 37.2 grams of Br2 is what I end up with. So now let's calculate that percentage yield. So my percentage yield, again, is always it's always going to be the smaller number over the bigger number. So in this case, it's always going to be your actual yield over your theoretical yield times 100. So what I actually got in the lab, that's what's given to you in the problem here. So that's 26.3 grams. What I should have gotten, if I did everything correctly, theoretically, I should have gotten 37.2 grams. And when I times that by 100, what do I get? So 26.3. So I get 70.7%. Okay, that is actually not a very good yield. Ideally, you want your yield to be over 90%, especially for this course. That's what you're sort of aiming for. So if you have something less than that, remember what I said in class. It doesn't mean that you're not going to get full marks for it. You just have to explain why you would have lost 30% of your product, which is a good chunk. So anyways, that's how you calculate percentage yield. You take the theoretical yield that you calculate. The actual yield is always, always, always given to you in the problem, unless we're doing a lab, and then the actual yield is what you actually weigh out in the lab. So that's how you do percentage yield. And oh, look at that, I even had steps already for you. So you are done Unit 3 of Grade 11 Chemistry. Hopefully you didn't mind that video too much.